Welcome to a lesson on exercise 8H, angles of elevation and depression. Now, angles of elevation and depression relate to how we speak about angles in real life. And I guess the idea is that in real life, when you're looking around, looking at the world around you, and you speak about how high something is and the angle with, the angle that that building or house or tree or whatever, the angle that that will make with the ground, for example, or your eyesight. And the thing we do is we use something called the angle of elevation. The angle of elevation is measured from the horizontal, which means that if you're measuring from your eyes, let's say those are your eyes, then you start measuring horizontally. That's the horizon, horizontal, and then we measure up. For example, if you want to know the angle of some, whatever you call this, no idea what you call it, parachuter, no idea what it is, glider, something of that. So anyway, how high that person is from you, you would speak about not how high someone is, but the angle at which you're viewing them. That's the angle of elevation. This angle, that's the angle of elevation. So the idea is you measure it from the horizon. When you measure upwards, if you're looking up from the horizon, if you look up, that's elevation. And from the horizon, if you look down, so for example, if you're the person who is gliding and you're looking down at a person, what angle, at what angle is that person standing? Well, you measure from the horizon. You look at the horizon, that's the horizon right there, right? And then you look down. Because you look down, it's called depression. Depression down, D, right? Depression down. And then elevation, elevate, to move up, So if you look upwards, it's elevation. If you look downwards, it is angle of depression. So hopefully you got those two terms. Let's move on. So the type of maths you'll need in this chapter, apart from SOHCAHTOA, what type of maths you'll need? First of all, you'll need to know the angles in a triangle add to 180. So that's a right angle, therefore that's 90 degrees. And so you have 90 plus 40 degrees plus x are going to add to 180. In other words, x will equal to 180 minus 90, and I should write degrees here. 180 minus 90 degrees minus 40 degrees, and that should give you 50 degrees. A shorter way to do it is because that's 90 already, then x and 40 have to add to 90 because you already got 90. So 40 and x will add to 90, and so x has to be 50 because 40 plus 50 equals to 90. Anyway, we've got our result. Point is, angles in a triangle add to 180 degrees. Next thing you'll need to know. Now, of course, if I label that as y, then you'll need to know that y is because that is a right angle. That's 38. Y will equal to 90 minus 38 because it's a right angle, and a right angle is 90 degrees. But let's say we're not using that. So you need to know, you need to know why, but also you'll also need to be able to use co-interior angles, alternate angles, corresponding angles. Now, notice that that line is parallel. These two lines are parallel. And so that angle and this angle are alternate angles. Alternate angles are equal. Alternate angles are equal. Now, some of you might remember this as the Z shape. The Z-shape one. Some students remember that way, right? So if you have two parallel lines, let's say those are parallel, and you have a transversal, you have a line cutting through them, then A and B will be equal. Okay, that's alternate angles. So just keep that in mind. The idea here is if you have an angle of depression, that's a horizon, right? And you have an angle of depression, and this is the ground, then that, if you draw that line there, this and this are going to be equal. Okay, just keep that in mind. We'll be able to use that somewhere. Okay, so let's get started. So to find the height of a building, Johal stands 85 meters away. So we have, that's the building, and that's 85 meters away from its base, and measures the angle of elevation to the top of the building. So if Jahal is standing 85 meters away. That's Jahal clearly. And the angle of elevation means that Jahal is looking up at the building, elevation looking up, and it's 70 degrees. Find the height of the building. Okay, so that's the triangle. That's the triangle we're dealing with. 70 degrees, 85 degrees. We're trying to find H, in this triangle. And so with reference to that angle, this is opposite and this is adjacent, O and A. And so Toa, Sokotoa, Soh, Kah, Toa. And because you have O and A, it's going to be Toa. Tan of the angle is equal to opposite, which is H here, over adjacent, which is 85. Multiply both sides by 85. So you have 85 tan of 70 degrees is equal to H, and therefore H. You just put on a calculator. You should know that by now. I'm just going to skip it so the video isn't so long. Just put on a calculator. I'm sure you should know that by now. Moving on. From the observation room of Centrepoint Tower in Sydney, which has a height of 160 meters. So clearly this is 160 meters. The angle of depression, so we're going to be looking down. So from the observation room, that's going to be right at the top. That's the observation room, right? And that's the horizon. And we're looking down. We're looking down. It's 8 degrees. And the height is 160. That's 8. How far from the base of the tower is the boat? So we have to find X. Now, we have a triangle, but within this triangle, we have no angles. The only thing we've been given is 8 degrees. Now, because horizon and the ground are parallel and the alternate angles, I know this is going to be 8 degrees. And look, if you wanted to treat this as a right angle and figure out that, what this angle is, you're more than welcome to do that as well. I just want to give you an example of alternate angles. So I've used alternate angles here. All right, anyway, 8 degrees, that's X. So with reference to the angle, that is opposite, and this is adjacent. And once again, we have a tan relation, TOA. O and A is TOA. Tan of the angle, 8 degrees, equals to opposite, 160 over adjacent, which is X. And we're going to multiply both sides by X here. So you'll have X of X times tan 8 degrees is 160. And because you want X by itself, I'm going to divide both sides by tan 8 now. So you'll have X is equal to 160 over tan of 8 degrees. You put that in the calculator and you'll get the answer. How far from the base of the boat? Correct in the Yep. And put in the calculator, you get the answer. Once again, I'm going to skip putting it on the calculator just to make the video shorter. Okay, find the angle of depression from the top of the hill to a point on the ground 50 meters from the middle of the hill. Answer to the nearest degree. We're trying to find the angle of depression from the top of the hill. So let's say that's the hill. That's the top, obviously. We're trying to find the angle of depression. Depression means you look down. And so we're trying to find theta. We're trying to find, what is theta? What is theta degrees? All right, and we know that's 50. So that 38 is part B. We're going to ignore that for the time being. We're just trying to find theta. And 50 degrees, 38 from the top of the hill to a point of 54 from the middle of the hill, answer to the nearest degree. Okay, I think we are going to need to use this 38. It's given in the diagram. So let's use that. Trying to find theta. Now, what is theta equal to alternate angles? This is also theta because horizon is parallel to the ground. So theta, can I find theta? With reference to this angle, that's O. This is opposite. This is adjacent. So tan of the angle is equal to opposite, which is 38 over adjacent, which is 50. And therefore, taking the inverse tan of both sides, because we're trying to find theta, to find theta by itself, you need to get rid of tan. To get rid of tan, you do inverse tan. So inverse tan of tan theta is equal to the inverse tan. Remember, if you do it to one side, you're going to do it to both sides. 38 over 50. And therefore, theta is equal to, and I will use a calculator now. So shift tan of 38 over 50 equals to capture screen. And it says to the nearest degree, so that's going to be 37 degrees. That's part A. That says, part B, what is the angle of elevation from the point on the ground to the top of the 38 meter hill? If you answer nearest degree, well, that's going to be exactly the same. Actually, that's how we figured it out. Yeah, so B is the same. The angle of elevation from the point on the ground to the top of the 38-meter hill. And so this is the angle of elevation. We've already found theta. It's going to be exactly the same because of my previously explained reason, right? The horizon and the ground are parallel. That's theta. And alternate angles, that's also theta. And so this is also to the nearest degree. So 37 degrees as well. Moving on. Oh, that's it for the day. So best of luck with the homework. As always, you can ask me for help on Slack. I'm more than happy to do a Zoom session for you as long as there are 2 students present. I will not do a Zoom session with 1 student only. Some legal reasons, and also I'm not comfortable Islamically as well. Anyway, 2 students or more, I'm happy to run a Zoom session anytime you want. But if you want individual help, ask me on the main channel on Slack. Do not private message me on Slack. Just ask in the main channel. The girls have a separate one, the boys have a separate one. Ask there. I'll help you guys anytime you want. Just please get the work done. Best of luck with the work.